This is a tutorial about how to do ROI analysis in AFNI. Remember that ROI analysis requires two steps. 1, creating a mask for our region of interest, and 2, extracting data from that mask. Today, we will explore 2 ways of creating masks. 1, by making a spherical ROI, and 2, by creating masks of the motor cortex using the Talairach atlas that comes with AFNI. Then we will extract data from those masks using the tools 3D Mask Av and 3D ROI Stats. So if you're feeling ready, let's get started. Let's look at our directory. We have 12 subjects, and within each subject's directory, we have a statistical dataset, stats.thesubjectname plus TLRC. I also have this file called subject list, which has each subject's name in there. We'll be using this for scripting later. Next, I'll copy the TT and 27 template from the AFNI binaries directory to my current directory. I warped all of my subjects data to this template, and I'll be using it to create masks and to visualize them. Before we do that, however, let's first create a 5mm spherical ROI. Let's say that we want to use the peak activation from another study at the coordinates 0, 30, 30. I'll be using the command echo to feed these coordinates to the command 3D undump. Then open up AFNI and click Overlay, selecting the new ROI you just made, and make sure that it's roughly in the location where you think it should be. Next, we're going to create masks based on an atlas. First, go to Define Data Mode, and then click on Plugins. From there, click on Draw Dataset. From this menu, select Choose Dataset for copying and the TT-N27 template. This creates a copy dataset that's all zeros but has the same dimensions and resolution as that template. We'll then be drawing masks on top of that. If you click on the Choose Atlas drop-down menu, you'll notice there are several different atlases. Some are in MNI space, but since we warped to Talairach space, we're going to be using that atlas to generate our masks. If you click the menu below that, you get a list of structures contained in that atlas. We're going to select the left post-central gyrus, which takes all the voxels that the Talairach atlas determines are part of the left post-central gyrus, and creates a mask by assigning a value of 1 to each of those voxels. Next, select Load Overwrite, which will create a mask in the left post-central gyrus. Check to make sure it's roughly where you think it should be, and then click Save As, and we'll call this left post-central gyrus, which saves that out as a mask of 1s only in those voxels we've determined to be the left post-central gyrus. Next, click on Undo to clear the mask, and then we're going to select the right post-central gyrus. At this point, go to Value and increase it to 2. The reason for this is because when we create the mask, instead of filling the voxels in with 1s, we'll fill them in with 2s. And we can use that with a command called 3D ROI Stats to extract data from multiple masks simultaneously. Now, same as with the last mask we did, we're going to click Load Overwrite, make sure it's in the same spot where we think it should be, and then save it as right post central. Once you've done that, close out of that menu, and we're now going to resample those masks to fit the same dimensions and space as our statistical data sets. We need to make sure that the masks match up both in voxel size and dimensions with our statistical data sets before we can extract any data from it. So first, we're going to use 3D Resample, select one of the stats data sets as the master and our different masks as the inset, and call them left PCRS and right PCRS. Next, we'll combine these two masks using 3D Calc. In variable A, we'll put the left resampled post-central gyrus mask, and in variable B, we'll put the right post-central gyrus mask. Use the expression A plus B, and we'll call this left-right PC. Let's see what that combined left-right mask looks like. Click on Overlay and select the left-right PC overlay. Then go to Define Data Mode and remove any spatial interpolation in the overlay by selecting Nearest Neighbor. Now notice that the left post-central gyrus mask, highlighted in yellow, has a value of 1, and the right post-central gyrus mask has a value of 2, matching up with the values we assigned to them when creating the masks from the TT Atlas. We've now completed step 1, creating our masks, And now it's time for step 2, extracting data from the masks, performing statistical tests on them, and then seeing whether our experiment worked and whether we're going to become rich and successful, or whether the experiment failed and we're going to become huge losers. Now in this experiment, I have left button presses and right button presses. In each statistical data set, the parameter maps for the left button presses are in subbrick 31, and the parameter maps for the right button presses are in subbrick 64. I'm going to use a for each loop in T-shell for all you haters out there, using the subjectlist.txt file to loop over each subject, and then using 3D bucket with the aglue2 option to concatenate all the left parameter maps for each subject into a single data set and all the right parameter maps for each subject into another data set. Once I have my 2 sets of parameter estimates, I'm going to use 3D calc to take the difference between them and make a bucket called left minus right. What this is going to do is essentially going to be a set of contrast maps for each subject, and I should have 12 total if I look at them with 3D info. I see the number of subbricks corresponding to the number of contrast maps and see that it is indeed 12. Now let's extract data from the left post-central gyrus mask using the command 3dmaskav. I'm going to give it the option quiet to suppress information I don't care about, and give it the mask leftpc_rs. The last argument is the left minus right contrast dataset, which tells it to extract data from each subbrick in that contrast bucket for the mask leftpc_rs. The output is 12 numbers, and each number represents the average parameter estimate for that contrast across all the voxels within the mask that I supplied. Now, not surprisingly, for the contrast left minus right, in the left motor cortex, that mask, the numbers are negative because right button presses should elicit more contralateral motor activity. We can see this again in the right post-central gyrus mask for that same contrast. The numbers are on the whole pretty positive. Now lastly, let's take those numbers and put them into our favorite statistical software package. In this case, I'm using RStudio. I put them into a variable called x and do a t-test on that array. Now surprisingly, within the right motor cortex, those parameter estimates for left minus right button presses is highly significant. One more command I'd like you to have in your toolkit is the command 3D ROI stats. It functions much the same as 3dmaskav. You give it a mask, you can give it the quiet option, and then you give it the contrast or parameter estimates you want to extract data from. Remember, in this case, we assigned a value of 1 to the left post-central gyrus, and we assigned a value of 2 to the right post-central gyrus. The first column corresponds to that first mask, and the second column corresponds to the mask with the value 2. You can add as many masks as you want to speed up your ROI analyses for several masks simultaneously. In this tutorial, I used left and right button responses because many studies have some kind of motor component to them that reliably shows activation in the motor regions. I want you to use these as a template for whatever you happen to be investigating. One exercise you can do is to create another mask using the Talairach atlas we just discussed, and assigning it a value different from the other masks. For example, a value of 3. Then, add this to your other masks using 3D calc and extract parameter estimates using 3D ROI stats. Do you see significant activation where you think you should? Another exercise is to take apart the contrast to see what is driving your effect, which you should do for any significant main effects and interactions. For the left-right contrast in this example, it could be that the significant effect in the right post-central gyrus is because left button responses elicit much greater activity than right button responses. Or it could be because right button responses elicit negative activity. Or it could be a mixture of both. The only way to find out is to use a tool like 3dmaskav to examine each separately. I hope you enjoyed this lab, and I wish you luck with whatever region you investigate.